I'm trying to see. Anyway, before I start talk, I think you all of you know that you are in Dallas. It is a very historical place. It says that it is ninth biggest city in USA. As you know, because it is historical, John F. Kennedy was assassinated in 1963. Rob, you know that, right? Right. And there's a museum, very famous museum. I have been there. If you would like to go tomorrow or day after tomorrow in the morning, you just contact me. I think I can arrange a visit. 3-4 people. We can have a taxi and go there. So contact me at lunchtime. Okay. So that is what I want to tell you. Now, I'm going to talk about part of my research. Let me tell you a little bit about my university. I don't know whether you can see here. You can see here is London, Canada. And I don't know, I came from India. I look like Indian anyway. Therefore, when I came from India, Now he's laughing at me. Now, when I came from India and to London, Ontario, my parents, I came from village, from Indian village, and when they were writing letter to me, they always used to write London, and then I never got their letters. And whenever I visited India, and they told me that we never reply our letters. So I said, you never wrote any letters to me. And the reason was that they were always writing London, England. All my letters went to England, I don't know where. And this is the worst name of a city where our university is located. It's a terribly bad name. And whenever you go to anywhere, you say, oh, you are London, Canada. They say, oh, weather is very nice, and Thames River is flowing. All sort of things, they think always England. That is one of the things I face when I go outside. But by the way, we have Thames River in Canada, in our city. Okay, so I think I want to just tell you that it is located, there are 5 biggest lakes on this earth. This is the most beautiful place on this earth. You cannot find better place to live by. This is like heaven, and London is here, and you can go to any lake, and especially, as you know, Canada is a cold country, and when it snows a lot, and when you are walking on the road, I walk to work every day. It takes me about half an hour, and I feel that I'm walking on heaven, beautiful trees and snow all around you, and it's so nice. If you guys want to really see the heaven, come to this place in winter time. Okay? And the Niagara Falls are here. I'm going to show you. It is about, I would say, 150 kilometers. Is 150. Detroit is also about 150 kilometers. We are not far away from American border. You can see this is Niagara Falls. This is sort of honeymoon of the world. A lot of people come there, and it's a beautiful place. This is Canadian side, by the way. It is somehow border, United States border goes somewhere here, and this is, most of the people come to Canadian side. If you want to come see the Niagara Falls, it's a beautiful place on this earth. If you stand near somewhere here, you feel so small. You will see nature is so beautiful. Close your eyes and hear the noise of Niagara Falls, and you feel really that you are somewhere living in this universe. It's a beautiful place if you have time. You have seen that lake if you're not. I would like to show you, this is at nighttime, they have different colors there. This is American side, which is, as you know, it's not as beautiful as, it's more uglier. Far Don't want to go to see American side. If you see, this is American side. If you stand here, you don't see that far, by the way. Therefore, it is useless to go to America. You have to come to Canada to see both parts. That's interesting. Okay, so let me continue. Okay, so I'm going to talk to you today on nanotechnology and nanomedicine. My talk will be very different to Dr. Mausa. I'm going to talk more about fundamentals. The starting point of my talk is really that in last century, we had aeroplanes, we developed aeroplanes, we have atomic bombs, we developed cars, we made computers, right? We have electricity and everything we will in the last 2 centuries, let us say, right? Now the question is what we will do in this century. What type of research we will do? Whether we will continue the same thing what people did last century, or we should do something new, right? Last century we discovered all sorts of materials which we use everyday life, like computers. Computers are made from silicon chips, silicon, right? Wires which are used here, they are copper, metals. So all sorts of periodic table. If you have learned in your high school or grade 5, periodic table we use most of the materials. The question is what we do in this century, right? Because challenges are different in this century, and medicine especially is very backward science. It's very backward, I would say. Medicine really, if you have a bad car, you take to garage, they fix it, and then your car will start. And if you are sick, if you go to the doctor will give you 10 medicines, and they will try that one of them work. You see, those are status of science. So now nanomaterials and nano things which have been discovered by the physicists. I don't know whether you have taken any undergraduate courses in quantum mechanics. Quantum mechanics is a classical physics, even classical mechanics. Like car moves and suns move around the Earth rotates. To understand these things, we need classical. Quantum is for nano. So we are taught from BSc what nano is. Okay, we are trained. I'm trained as a nano scientist. I worked with many people in nano. At that time, we do not call nano. We call it atoms are nano, basically, right? Atoms, when you study atoms, or chemical reactions, when you want to see, they are all nano. They are size very low. Okay, so that's what I'm going to talk about. So I'm going to talk about really what you do this century. Okay, so in this century, what people are trying to do is like computers. People say are medical treatment. Okay, so this century they belong to the medical science. I would say how you can invent or how you can improve or you can treatment for different things in this century, and also then how you can increase the speed of computers. Are these new type of devices which you can make it. We have to have some devices different, right? Computers, they say silicon technology is gone. Maybe 10 years, 15 years more, after that we do not know what will happen, right? Therefore you have to have something new. So to have something new, what do you have to do? What you have to do is that you see around, this is the way we did sort of discover, electricity, cars and atom bombs. They were materials in the nature, but we have used everything in the nature, right? So what people are doing now, scientists, what they are doing, they are making new type of materials, okay? So that is the talk of my talk. You have to make your man-made material, so human-made, not man. Before people, I remember that when I was growing up, at that time we said man-made, but now this is not man-made. Romans are more better scientists than men. They are highly intellectual people. So it's more human-made, and materials, and we have to really use them for different purposes. That's what I'm going to talk about. Okay, today. Okay, I want to impress you that really I worked in Egypt. I visited many places. So I work all over the world just to impress you. Okay. Now, what I want to tell you that there are man-made materials, which I will explain a little bit time on them. So let me talk about hybrid nanomaterials, what they are. Okay? Because when you take this is gold. I said metallic nanoparticle. Gold is sort of gold is about this is 10 nanometers or 50 nanometers. I think you heard what nano means. No, different one. So these are really gold particle. No, that side. And gold itself, I'm going to tell you what is its application, but itself is not sufficient. You have to make new type of materials. You have to develop your own materials. So that once you develop your own materials, a new thing, you can use it according to your need. Like silicon, the light which you are using here, there's a particular, and therefore this will emit only the white light. But if I want to have different color, I have to use different material. You cannot use the same material which is used on the slide. So therefore, I want to have a material which emits white light and also blue and red and everything. I just click it and it becomes black. It emits the same thing. So that is really control what human being, as a human being, that is our job. We have to invent something new. We cannot use the same thing which we were using centuries and centuries. Okay, so that is the name of the top. So therefore, there is a quantum dot. These are by the quantum dots are semiconductors like silicon, and if you make it about 10 nanometers or 5 nanometer spheres, so these are called artificial atoms by the way. Okay, so you can together this is called hybrid. Means you are taking metal and semiconductor together, the hybrid. You can mix a lot of things. You know, I talk about graphene. There's carbon nanotube. These are all nanomaterials, okay, which are used for medical applications. And of course, making nanotechnology, new type of devices, new type of things. You can make aeroplanes, for example, which are very lighter and very strong. Even though when they collide, nothing will happen. When they fall down from the air, nothing will happen to those. And these are the materials you are inventing. And that is called graphene. So if aeroplanes fall down from far away, it will not damage. Okay, it's like soft, strong material. Okay? So these are the new things people are doing, and that's what I'm going to talk a little bit about. I think in previous lecture you have seen the application of nanomaterials, so therefore I'm not going to really talk about that very much. I will tell you a little bit more. Anyway, let me emphasize one more point here. One of the most important thing is that if you take a gold particle, right? Gold particle is one particle, one thing. But if you make a hybrid material, you can make millions of materials yourself, mixing different type of materials and studying different science. They have different properties. When you put together two materials, I will show you, they are very different than the actual material. Okay? So, and how you can use them for medical application, I will give you some examples. Okay? But there's another thing has been invented in research called metal materials, and these are new type of materials, amazing properties, and I will show you a few different properties of these materials. Okay. So hybrid materials, I think the interesting point about them is because the light which is coming laser, like we treat in medical applications, laser applications, and they have different properties, and you can really control them as you like. Okay, let me tell you about quantum dots. Now, quantum dots are quite used in medical applications now. There are huge applications of these, and so therefore let me explain you what they are, because sometimes it's very important to know what they are. Then you know how to use them, right? That's the point. The quantum dot is sort of a spherical size, and the size is about 10 nanometers, and they are made from semiconductors like silicon, germanium, you may have heard about that. And they are called quantum dots. You can call it nanocrystals. You can make nanowires, and these quantum dots emit different type of light. If you make quantum dots here and put in you can see they emit different colors. the same material with different type of colors. Right? Like if you take silicon or fluorescence light when you're driving a car, it emits only one type of light. But these quantum dots can emit a different type of light. This is fascinating. You have control, human control. These are human-made materials. You can make these materials. And why they emit light? But I don't understand that light is only emitted from, you know, atoms have 1s, 2s energy states, right? So you have learned in high school. So they are energy states. Light generally emit, and the electrons fall down from excited state, this energy state to that energy state, lights come out. The light which is coming out, by the way, it is from atoms, and the electrons that fall down, and the lights come out. Okay, so this is the light. The light is dependent upon radius squared. So what is the radius of this quantum dot? And then light comes. So therefore, you can change the size. You can make them. These are quantum dots. I make it. Therefore, you can make the different size. And when you change different size, you get different colors. And the people make these type of. Okay, so that is one material. There is another material called this metallic nanoparticles. I think all the universities there was time when you have metallurgy. People used to do in engineering departments and metallurgy was doing research in metals. And then every university in all over the world, they closed down metallurgy departments. The reason why they thought metals are useless. Hey, we know everything about them, and we don't need to have. We don't train anyone on metallurgy. But since that these metals are useful, now these metallic nanoparticles are very useful to make new type of devices and medical applications, as you were saying. So therefore, there's a lot of interest now in metals again. Okay. So now the metal nanoparticles are metals are like gold, you know, metals, copper, so Ag, for example, these are metals, and metals have 3 electrons. And there's a new particle you may not have heard about. Graphene is a new type of particle. Nanoparticle has been invented recently, about 10-15 years ago. And there's another material, metamaterials have been invented. And the property of these materials are, they are like atoms. No? Atoms, simply when you talk about atoms, simply means you are talking about quantum science or nanoscience. When you are talking nanoscience, you are talking about that electrons have quantized states. Okay, so like when I'm walking as a person, you see, I walk 1 feet and 2 feet. I don't touch on the ground. Okay, this is called quantum walk. The human walk is quantum walk. But when snakes walk, they touch each point. That's called classical walk. So therefore, energy in these quantum nanoparticles is quantized. It has this energy, and that energy. Therefore, you cannot really stay in between somewhere. Okay, this is the law of science. So therefore, they have energy, quantized energy, and the electrons, 3 electrons move around here, and the energy states of electrons in quantum dot in metallic nanoparticles have quantum energy. The light which is coming here is quantum energy. That is called photons. That's what Einstein said. That light is quantized. Okay, this is all nanoparticles we are talking about. Okay, so I think previous speaker was telling you these quantum dots, how you can prepare them for medical application. Like I told you, the quantum dots have quantized states, means they have energy state which is quantum, which is step by step, and the light comes out with one particular color. When you talk about particular color, means it has one frequency or one wavelength. Okay, and this is quantum energy. Okay, this is called nano energy, whatever you call it, it is quantum energy. And therefore, here these are atoms, silicon atoms. You can coat them with different, because quantum dots, silicon, semiconductors are toxic. You have to coat them with different materials so that they become not toxic. After that, you just functionalize it and for particular applications. So you have to do some work, and I know, I'm sure that medical people who are, I'm not a medical person, I'm more very interested to find new type of materials which can be used for medicine. That is my role. I interact with medical doctors and in my university and all over the world who really use them, okay? And they tell me how they do that, okay? That's what. Okay, so let me tell you about new types of nanomaterials and nanoparticles have been invented recently. In fact, this gentleman, this is sort of a, there's a material which is called graphene. It acts as a metallic nanoparticle, and also it can affect the quantum dot. It has two things, very, very different. Metals like gold and silicon are two different materials. Okay? Gold and silicon. Gold, we can use gold watch or gold rings, but you cannot use them for making computers or cell phones. You cannot use them. The gold cannot be used. Only silicon chips that can be. But this material can be used to make a gold, and this material can be used for semiconductors, or you can make computers out of it. Right? This is beautiful things. Right? These are beautiful things. And it was invented by the called Professor Wallace in 1947. He was a professor at MIT, he's Canadian, and he, at that time, in 1942, at that time, people are making atom bombs. He was in charge of making atom bombs with Einstein and that group. There were many cells all over America and Canada, hidden cells, and he was the lead of one of the hidden cells. And his job was to how you protect when an atom bomb explodes, how you can protect it. And graphite was one of the materials at that time. He was working because graphite, if you are surrounded with graphite, then you can escape from this explosion. No, nuclear. And basically, graphene is made of graphite. If you take a pencil, for example, this is graphite, and if you make a line on the paper, that becomes graphene. Okay? So graphene is nothing but if you take a pencil and write something, and that is graphite. Okay? And that graphite, later on, two Russian scientists really made the graphene. That was a more theoretical paper like E equal to mc squared. Einstein, he worked with Einstein also, by this gentleman. He worked with Einstein. And N.F. Mott was another Nobel laureate. So he worked with many people. And therefore, 2010, you see, 1947, about 50, 60, after 60 years, these two Russians made graphene experiment. That was more theoretical work like E equal to mc squared, which is theoretical work which Einstein did. These people are trying to prove Einstein theory, and but his theory was proven into that, and they got Nobel Prize. Now, he would have got Nobel Prize alone, but he died in 2006. Okay? But that is an interesting thing. That's what really science is. This is the way we can. And why I'm emphasizing Professor Wallace? Because I worked with him for 5 years. We published about 15, 20 papers, and we invented new type of other materials similar to graphene. Okay, so graphene, I was trying to tell you, I wanted to teach you that, of course, we can use these nanoparticles in medical application, but in the same time, we have to invent these particles. Okay? It is not that suddenly nanotechnology or nanomedicine become nanomedicine without groundwork, without fundamentals. You can hardly do that. Okay, application is job for engineers and for medical. Okay. But someone has to do invent these things, and that's what people like scientists do that. Okay, that is their job. So therefore, what really graphene is nothing but carbon atoms, and they form honeycomb structures. And this is just two-dimensional materials. Just purely two-dimensional materials, like here. Like me is three-dimensional. You know, this is three-dimensional. Art is three-dimensional. Art is three-dimensional. Everything is three-dimensional. But two-dimensional. Do you know what two-dimensional means? This is something sheet. Very thickness of that sheet is about 0.1 nanometer. people are making those things. Okay. 0.1 nanometer thickness, and this is a seed. And this seed is so strong. If you, aeroplanes, people are trying to, European or European Union has spent about $10 billion on graphene alone to develop new type of devices, and one of the applications is make aeroplane seats. And they are so strong, take about 5 times more than iron. It is so powerful materials. And just I want to just show you here, some of you may not know, we always talk in science, energy. Energy is the basic thing for everything. Energy, if you want to understand what energy is, you understand everything, whether you are engineer, whether you are medical doctor. Once you know what energy is, then here is energy. Therefore, energy difference, there is no quantized energy. So this is like metal. If you have difference like here, so here this is no energy. So this is called balance band, this is called conduction band. Means energy is continuous here. But you can, if you go here, energy is not continuous. So therefore, when energy is continuous, they are called metals. And when energy is not continuous, there is a gap, and they are called semiconductors. And that's why semiconductors we use in computers, cell phones, everything. Not any technology. This is using semiconductor ones. Lasers are produced by semiconductors. So therefore, you have to have gap, and this material has both metal and semiconductor. That's what I want to just prove. Okay, now why these materials are important, I will tell you. Let me go a little further. Why these materials are useful for cancer or heart attack or eye operation, why we use them, okay? So I will give you the science behind it. The science behind it is that if you take metallic nanoparticles and you put, let's say, cancer cell, if you put inside the cancer cell, so what happens, these metals have 3 electrons, by the way, okay? So these electrons will vibrate along the surface, and this is, let us say, cancer cell around it. And then what happens, and the light which is coming out from here, maybe I can see next slide. No, I don't have here, but here. So the light which is coming out from here, like if you want to burn a cancer cell, okay? So what happens, the light which is coming out from this metal, it has to be quite intense. It has to produce heat. When you throw a laser light, by the way, Reagan was the president of the United States, and he was trying to make Star Wars, right? You are making lasers so that you can burn aeroplanes or burn anything, right? So that's what light does. Light creates heat, okay? So that is therefore you want to create a heat. So therefore here, this is just, we like the equations, I think you have learned equations in your high school, that when this is numerator, this is denominator, and denominator if is equal to 0, this becomes very huge, and you get sort of light intensity become very, very large. Okay? So that is the condition what people really create when they are making for cancer treatment. Okay? And you have to choose sort of a directly constant metal in such a way that you create a huge electric field. You can control, and this is the way you can, by using this metallic nanoparticles, this is the way the directly constant, you can choose number of electrons here, and if this condition is satisfied, then you can use for the cancer treatment. Otherwise, you cannot use this. You have to create these conditions for life. So this is the main application of cancer, heart attack, everywhere when you put it, like heart attack happen when the tubes become narrow, okay? And tubes become narrow because a lot of junk is created in the tube. You can put these nanoparticles and burn that area, and this is the way you can destroy. This is the main application of these materials, metallic nanoparticles.
let me go further. You have to let me know, by the way, how much time. I can stop any time, okay?
12 minutes.
Okay. I think drug delivery, I think was talked in my in the previous lectures. I was talking about this different, I already talked about that. I want to talk about the hybrid system a little bit. Hybrid system is, I think you have to, you guys are all scientists. I assume that you have taken a science in grade 10 or grade 12, okay? Can you raise your hand? Have you taken your science in grade 10 or grade 11? Everyone has taken, right? No. So that is the level I'm talking here, okay? When you are taking science in grade 10 or grade 12, you know equations, you use equations. And that, of course, I'm not telling you how you get these science. Of course, you have to do a lot of research. You have to know quantum mechanics. You have to know a lot of physics, like E is equal to mc squared. When Einstein produced it, he worked 5-6 years. This is not that he just got it. You have to know the background. Okay? So that's what we do here. Okay? So like these slides were made by my graduate students. Therefore, if you take a gold and put a quantum dot, gold I told you metal, okay, and quantum dot is a silicon, like semiconductors, okay. Semiconductors, the property of semiconductors is they have gap, energy gap. Metals do not have energy gap. That is why we use metals for electricity, because current can flow in metals, but in semiconductor current does not flow, okay, does not flow at all. So therefore, this is the difference between the two materials. If you put together, and what happens, these particles are neutral, like my hand is neutral, but if you put your hand near the electric outlet, you will be attached, right? So therefore, I'm neutral, but when you put in near the electricity, I become positive, negative charge, and I will get attracted. That's exactly what happens. When you put a light, and this light and this particle and interact with each other, they attract each other, they form a new particle, okay? Because you are throwing light inside, they become new particles, and they have very different properties, okay? And the same thing here, I'm talking about graphene, which is new particle. You can put a quantum dot, and they create a sort of new type of particle. And they have the same property as I was talking to you, that when denominator, this numerator, this denominator becomes 0, if you have 1 divided by 2, you get 0.5, right? 1 divided by 2, you get 0.5, and 1 divided by 0, you know what it is? Infinite. 1 divided by 0 is infinite, huge. So that's what happened here. If you have something divided by 0, you get huge electric field. And that's what the new materials create. And this is the way you destroy the cancer. If they are near the cancer, they produce huge intensity of light, and they can destroy the cancer or anything you want to destroy. So this is the way. This is the basic idea about these materials, and you can do that. Okay. Like I think one of the example in previous lecture was mouse. You cannot see anyway. Anyway, whatever. When you don't put nanoparticle, you get C picture. But when you inject a nanoparticle in a mouse and throw the light, you can see that where it is located. You can locate the cancer cells where they are located, because when you throw a light, I was telling you, these nanoparticles emit in quite huge intensity. This is the way you can do those things. And for example, Alzheimer, there is a treatment. I don't do research. I just found these references from different groups. And as you can see, this is a nice pure good brain, but when you have Alzheimer, there is a beta protein is collected, and you can inject these nanoparticles here, attach it, and when they are attached, you throw a laser light, and then you can destroy, like here, for example. This is before irradiation. There is no light. When you throw light and nanoparticle, you can just clean it up. So these are the experiments have been done on these things. Okay, another interesting point which I want to tell you. it's that quantum dots. I was telling you that when electrons fall from high energy to low energy, because here is a high energy, when I leave it goes down. Okay, the electrons fall down, and that energy is converted to the light energy. By the way, energy is conserved. That's what we talk about. Energy is conserved. Everything is conserved in this universe, and therefore when it falls down, it emits light, and that light you can change the side. This is light emitted. If you put metallic nanopart together, you can see huge intensity. You see, only quantum dot has very small intensity of light, but when you put quantum dot, it becomes huge. So these are the few advantages, interesting advantages you can make for application in medicine. Or making new type of devices. That's the aim of nanotechnology. Therefore, that's what happened. And here, for example, quantum dots have been used for medical imaging, for example, because quantum dots, as I was telling you, that different size they emit different type of light. So you can see the light emission happen where you find these quantum dots. Okay, so let us see. Another, I think, aim of these materials are how to sensors, how you can find out what type of disease that person has. Okay? And they are made as sensors. You can make these quantum dot sensors. I will give you a very simple example. So if you take, let us say, a quantum dot, here. You take a quantum dot and put a blood. There is some experiment, people have done it, and like down here, they have done what they do. They took the quantum dot, and what they did, I think molecular beacons, they surrounded it. Our blood, or any cancer cell, anything you can do, surround these quantum dots. And what happened, this equation I was telling you, that as you change the surrounding of the quantum dot, your intensity of the light was before that, when you put something, its intensity changes. And when intensity changes, by change of the height, you can distinguish whether it is blood, or whether it is cancer cell, whether what type of bacteria, what type of things is growing there, what type of atoms or what type of molecules are around this cancer cell. You can detect by using this simple equation, like E is going to here is directly constant of blood, directly constant. You just put it there, and everything is known in this equation, and you can really find out that what type of disease, what type of things is involving for a particular thing. So these are very simple. Of course, it needs it needs some In fact, you can make a more faster computer. Let me tell you here. I think, let me go out of the. You can make also computers, because see, as I was telling you that now the computer which we are using now, they are made of silicon chips, okay, and you cannot make smaller silicon chips anymore, okay. This is just the biggest limitation. So these quantum dots these nanoparticles are so small now, and you can really make them more smaller computers by using these nanoparticle type fields. And how you can make it? Very simple. I don't want to go in details, but the quantum dots have energy states, and if you put a metallic nanoparticle nearby, you make a computer. Okay? You take a quantum dot, a metal part, and it is computer. Okay? And now this computer, you can on and off, and you make it 0 and 1, and that's what computers are run by 1 and 0. You have to have two numbers, and once you have two numbers, you can calculate anything. You can have pictures, anything you can want to. So that's what I want to show you. So this is sort of a 1, and this is 0. So when you put quantum dot together, when quantum dot is alone, you can have only one picture, but when you put metallic nanoparticle, you get 2 peaks. So you have 1 peak and 2 peaks. 1 peak can be 0, and 2 peak can be 1. By changing the distance, you can really create these type of computers out of these materials. let me know, okay? When my time is over, let me know. 3 minutes, okay. So I have total 3 minutes. Therefore, what I can do, these are nanomaterials we are building at Western, and I don't want to go. In medical science, people are doing that. So let me show you my last slide because I have 3 minutes. Yeah, I think this is a very interesting thing I want to show you. I think these are photonic crystals. These are. Have anyone has heard about this mechanism? Photonic crystals? No. Okay, good. I'm glad. I know more than you have, right? Because I know these two concepts. When I teach my students, I have about 500, 600 students in my class. My class is huge, whole auditorium is full of students. And my English is Indian English, and those Canadians cannot understand my English, right? And then I have to teach 500 people, right? And with my Indian English. So what I try to tell them, I brainwash first. Firstly, what I do, I brainwash them. I said, I write my name in Sanskrit. I said, how many of you know my name? No one. Right? No Sanskrit, right? Or Hindi. I said, one thing you guys know, that I know more than you. I know more, one language more than you know. Okay? So this is the way I start dominating my students. And then everyone is happy, everyone laughs, they enjoy my talks. Okay? You have to do fun of yourself. So this is the way, so I prove that I know more than you. I know about photonic. I did do research on photonic crystals. And these are materials. Light, for example, always travels in straight line. It goes from here in straight line. You cannot bend it. Wire, you can take it and bend it. But light, you cannot bend it. You have to have mirror. You have to put mirror and it reflect, right? You cannot bend the light. You know that? In nature, you cannot bend the light. On the mirror, you can put it bend light. But there are now new type of materials that is invented. You can bend the light. You can see it. Sorry. I don't know what happened, but how I can go more faster. I'm very old, traditional type of guy. I wanted to show you this picture. It's very interesting. At least you will know. Okay, I'm very close. Yes. Therefore, I want to just, if I can, run that. So you can see here, you can see here, light goes here, it bends 90 degrees. On this, till about 10 or 15 years ago, you cannot do that. Now you can bend the light. And this light is now used for laser surgery. Because when you are putting your wires inside the body, it bends all sort of angles, right? And this type of materials have been used now to make laser application because you throw the light, it bends everywhere and goes where you want. This is beautiful. That's our photonic crystal. You can bend them as you like, and that's what. Okay, and my last slide is this. I don't know whether you have been in Australia. It looks like sort of Sydney Opera House, right? Looks like, right? This is one of the pictures I created on one of my papers. When I wrote this, these American journals are the most important journals. I did not about this paper, physics and science. Americans and then British and then the rest of the world. So American journal, they said, no, it don't look like Opera House. You take out this name. And I took out this name from Opera House. And they put it in their website because it is a beautiful picture. Anyway, so I talk about nanoparticles and I showed some applications. And aane ke liye dhanwad. How many of you understand that? You understand that? This is Sanskrit word. Dhanwad is thank you. Thank you very much. And Sanskrit is one of the oldest languages by the universe. Grammar and these are my favorite lectures for my students. Grammar idea came from Sanskrit. Therefore, English, French, all the languages on this universe are based on grammar. And grammar was invented in India. And this is the way we use noun, pronoun in Sanskrit and French. And there are another type of language which are Chinese languages, which are symbolic languages.
I spent about 1 year in Japan, and I learned a little Japanese there, but it got more difficult for me to learn Japanese because it does not have a grammar idea.
Thank you very much for paying attention.